In this AstroPictionary Math problem, we would like to calculate distance d, speed s, or time t. We're given planet Mercury, and we're given Mercury's radius is 1516 miles, and you have a walking speed of 3 miles per hour at Earth's surface in Earth's gravity. We want to find the time and days to walk at this pace from equator to pole. So we have a relationship here between distance, speed, and time. Speed, s, is equal to the distance divided by the time. Now we just happen to be given speed and we're given some part to calculate the distance. So we need to solve this for time. So time is just the same thing as distance divided by speed. So that's the equation that we're going to use. We're given for distance the circumference of a planet or a circle. Notice how round Mercury is, so we can pretty much treat it as a circle. The circumference is the distance that goes all the way around. So you see it's in blue, whereas the radius is just the distance halfway through the circle or planet. So we want to find 1/4 of the distance because you're stuck here. You were dropped off on planet Mercury and you have to walk at 3 miles per hour all the way up to the poles where you find the ices. And so we need to figure this out. So we want to find time, which is equal to, from our equation, distance divided by speed. And now we need to know the distance. Well, the distance is circumference, but the circumference is all the way around, and we only want to go 1/4 of the circumference. So it's going to be 2 pi r divided by 4. R is the radius, and the reason why we're dividing by 4 is because we only want to go 1/4 of the way around the circle, and we keep our s speed in the denominator. Still keep our 2 pi. We know the radius of the planet. The radius of the planet is 1516 miles. And I'm just going to put an mi for miles. And then we're going to divide this by 4 times the speed. And we're given a speed of 3 miles per hour. So I'll put my miles in the denominator. And then per hour means that hour goes in the numerator, because there's your miles per hour. So now we can cancel like units. So miles cancels with miles, and we're left with hours in the numerator, which is expected because we're solving for time. So time is equal to 2 pi, so let's plug that in there. So I go to Google and type in calculator Google, and I get it. 2 times pi equals, and now I need to multiply that by 1516. You hit the equal sign, and then divide by. We have to divide by 4 and 3. So we divide by 4 and we divide by 3, and we hit equal to. We get a value of 793,775. Let's look at our sig figs. We've got 2 pi. 1516 can be a 0.0, so there's 5 digits there. We've got a 4 and we've got a 3. So it's actually 3.0. So we only have 2 variables, so we can only keep 2. So this would be 7.9 times 10 to the 2. So we keep our value 7.9 times 10 to the 2. And our unit is hours. But we're not asked for hours. It's asked for days. We want to know in days. So we have to get out of hours. Well, we know that there are 24 hours in a day, so we build our railroad track. We put in 24 hours in one day. And let's get our final answer. T is equal to, I'm just going to go ahead and keep our values here and just divide by 24. And we have 33. 33 days. Put a circle around that or a block. So the time it takes for a human to walk at a pace of 3 miles an hour if dropped off at the equator to reach the pole is 33 days. So that's too long for a human to survive unless you're in the nighttime side, but then you'd be freezing anyway. So you need some kind of heater or suit. So you're better off having a dune buggy with you, or a moon buggy, or in this case, a Mercury buggy, to get yourself from point A to point B.